Welcome to normal distributions, where we're going to be given the probabilities and we need to find the either z-score or the data value that fits with that particular probability. Again, on the TI-84 calculator, this is what we would use the inverse normal distribution feature for. However, we're going to use the numworks, which is you're going to see is very similar to how we did the finding the probabilities when we were given the measurements. Okay, so here we've got find the indicated z-score shown in the graph. So notice this is a standard normal distribution. So on our calculator, we go down to distributions, we go over to or down to normal, and since it's standard normal, it has a mean of 0 and a standard deviation of 1. That's always going to be the case. So what we do here is we want to find the area below this z, or well, not the area, we know the area is 0.1093, so 10.93%. So remember, we have three different tools. We have the below, we have between two values, and we have above. So for this one, we're going to use the below. And instead of putting a value in here, which would be the z-score, I guess you could plug in and just kind of check till you get it. But notice if we come over here, we can enter in the percentage, 0.1093. As soon as we hit execute, it finds the z-score for us. Notice it's a negative z-score, which makes sense because it's below 0. And so that's what we put in here as our answer. Find the indicated z-score. What is z equal to? Well, z is equal to negative 1.23. And most of the time they want 2 decimal places for a z-score. For the area, we'd like to get 4. Okay. Find the z-score that corresponds to the cumulative area. Cumulative area starts at the beginning, goes forward. So it's really the same thing as this, but we don't have the picture. But we know we've got about 79%. So hopefully you're thinking, well, that's more than the mean, right? So it's going to be a positive z-score. But again, all we have to do is fill in the percentage at 0.7936. We hit enter and it gives us the z-score. We see it is definitely past the mean and it's on the right side of the mean, but it's just the area below, which looks about like 80%, right? 20% not shaded, 80% shaded. So we have our z-score here as well, and we can just write that in. It's this number here. Z equals positive 0.81. Now we're going to round up, so the 9 has a 7 next to it, so that gets rounded up. 9 gets rounded up, that makes it 10, so it carries the 1 over, so it's going to be 8190 to 4 decimal places. But you see, we're using the tool a bit slightly different, but it's very similar to what we were doing in the previous set. So I think I can bring this. No, I can't bring that. We'll leave that there. Let me clear this out. Now, another thing that we do here, though, is understanding the language. The z-score that corresponds to p sub 8. P sub 8 is symbol for a percentile, 8% percentile. So that P is a percentile. 8 says 8%. So what that's going to be is 8% is below. So 8% is whatever it is. Say this was, it would be the area below that score. So that would make that the 8th percentile, right? That's what we're looking for. So again, we're still with the less than tool. but this time we just put in 8%, which is 0.08, right? Be careful, it's not just 0.8, because that would make it 80%. We do execute, and it's this little piece down here. That's our 8%. 8th percentile occurs at a z-score of negative 1.41. Again, so in this case, the z-score z equals negative 1.41. And if you know, because the way the tables are set up, z-scores beyond 2 decimal places are really not very helpful. You can't look them up on a table. We could look them up here. So you know, it depends on how much accuracy you want. We could use more decimal places, but this is generally what we're going to be using. Okay. Oops. Let me back up. There we go. So for this one, find the indicated z-score shown on the graph. Now this one's a little different. We've got this area, but notice this is area to the right of some z-score. And so what we have to do here is we switch our tool to going to greater than, to going to the right. Yes? And again, since we have the area, this is a z-score. What we want to enter is the area, 0.0446. Okay, so that's our area. We see we're getting the right, we're getting it to the right. We need a z-score of 1.6996. So that 6 will round up to 9. The 9 will round up the next 9. That will round up to 6. So for 2 decimal places, we will be going to 1.70. Okay, but you see the graphical, we get a match up. This looks like what we're getting. So it's a very intuitive tool. And then now we can use this information to solve whatever problems we have. Let's get this out of the way. Sometimes we're given a percentage, distributions area to its left. So we can, again, just enter this in. But what we're going to find out is we need to have this as a decimal. So you divide it by 100. And this is going to be 0.05071. That's the area. That's what goes in the shaded area, shaded region over here, this gray shading. But in this case, we want the area to its left. So again, we have to just make sure we're using the right tool, which is the left tool, the less than tool. And we just come over here and we enter our value, 0.05071, and we've got our z-score. Again, typically, if the instructions are different, but typically they'll want them rounded to 1 decimal place, so that z equals negative 1.64. And you see, it looks like about 5% is just a little bit in this little corner here. Got our answer. Again, as we move forward, we'll start using these answers to answer more interesting questions than what is the z-score, like this. So this one kind of shows us what we're going to get. So we've got a survey of 18-year-old males. The mean weight, so this is, and I actually, that was about what I weighed in high school. I don't weigh that much anymore, but 169.8 pounds with a standard deviation of 53 pounds. So that's 53 pounds plus or minus. Remember, assume that the distribution can be approximated by a normal distribution. We're going to see how this will do it. Again, in the older days, we would probably have to, we would have taken these values, and when we go to answer these questions here, back up, we would have needed to change these into a z-score and then use the inverse and all this kind of stuff. But what weight represents the 97th percentile? Watch how we can do that here. First of all, we need to back up, and we need to go 169.8 for our mean, and 53.4 for our standard deviation. And now look at our chart, has all this stuff in here. What's the 97th percentile? Well, remember, that's 97% is below, area below whatever score this is going to be. So that's to the left. So remember, 0.97 is really what we're looking at, to the left. Now remember, 0.97 is an area, and so what we do is we make sure we have the right tool, which we do. We have the area to the left. That will always be the case when we have percentiles. Now we enter the area, or the percentage, 0.97, and we hit execute, and we see the shaded region is 97%. That's a weight of 270.23 pounds. They don't tell us what to round it to, so again, look at that when you're doing the questions, but the answer here would be 270 point, let's just use 1/10 of a pound. I think that's probably enough. 270.2 pounds. And notice this tool gives us directly the answer directly in pounds. And okay, so let's see the next one. What weight represents the third? Oops, I got too far. What weight represents the 46th percentile? Very similar. We're already set up. All we have to do is actually nothing much here. We've got the right tool. We just changed 0.97 to 0.46. Execute, and we've got our weight. This is somebody, and again, that's, remember, 46%. The mean, if we were at the mean, that would be 50%, right? The mean is always the 50th percentile, so it's a little bit lower than the mean, a few pounds, 5 pounds or so. So that would be 164.4 pounds. And then the last question here, as we were what weight represents the third quartile. So they're kind of switching here, so not percentile, a third quartile. Remember, a quartile is divided into 4 pieces, or 25%, so if there's 3 of them, what we're going to be looking up is 0.75. How 75% is below. So again, we come over here, all we got to do is change this 0.46 to 0.75. Much cleaner calculations allow us to focus on solving this question, answering these questions, because the answer we get is directly, it's in pounds, not z-scores that have to then be converted back to pounds. 205.8 pounds, and that's what it is. Okay, so having the proper tools that allow us to calculate, to see, to verify, and get all the values that we need is very beneficial for us. And that's our lesson for 3. You'll be able to go through and answer questions like these. Some will involve a little bit more problem solving, but you will use this tool in that same way, given the percentage, what is the z-score, given the percentage, what is the actual measurement from the sample of data that we have. All right, thank you so much.